Okay, so we'll continue today, lecture 3 of 5, binomial distribution. So what you're going to learn today is, at the end of this lecture, you should be able to determine the probability of an event when the probability is greater than or equals to 0.5, determine the mean and variance, and we're going to solve problem in social sciences and management. So what actually we're going to do today is we're going to find the probability where P is greater than or equals to 0.5. Look at the probability, 0.5 there, 0.5, okay? So the highest probability is 0.5. So we're going to use this guide, means that we're going to do the opposites. This is actually just an options. Ini cuma sebagai option saja. There are 3 things now, okay? Ada 3 benda dah kita boleh buat dengan binomial sekarang. First, the formula. Second is using table. The third one, this one. If you don't want to use this, it's okay. Ada 2 lagi benda. If x is binomially distributed with n is 10 and p is 0.6, find using the binomial table. Okay, now we're going to use the binomial table, but it is impossible because our p is 0.6. Impossible. How are we going to do that? We're going to change the variable x into variable y. The distribution is still the same, still binomial. And also the same. Just that if you have P 0.6, when you do the opposite, you're going to do 1 minus 0.6 dapat berapa? 0.4. So if you have x is less than or equals to 5, x will become y. Less than or equals to will become greater than or equals to. It becomes the opposite symbols. So what we're going to do next is, okay, here, okay, 10 minus 5. This 10, you minus with this 5. What you're going to get? 10 minus 5 is also 5. Okay? This 5 is also 5. No. Now, can we read from table? N is 10. P is 0.4. We can read from table. Okay? Baca table you. So, N is 10. P is 0.4. Okay? Y greater than or equals to 5. So, we're going to get the probability 0.3669. Now, probability of x equals to 4. Okay, so we're going to do the opposite way. How to do this opposite way? So, x, it become y equals. There's no symbols can be changed. Equals will still become equals. 10 minus 4, what is it? 10 minus 4 is 6. Okay. So, what we're going to do next, if we're using table, probability of y greater than or equals to 6 will minus, what is the number after 6? 7. So we're going to minus with probability of y greater than or equals to 7. P 0.4, y greater than or equals to 6 is 0.1662. Okay. Minus with probability of y greater than or equals to 7. Okay. 0.0548. Okay. I hope you can read that one. So we're going to get 0.1114. Probability x is greater than 1 and x is less than or equals to 4. If we do the opposite way, what we're going to do is the probability, okay, the probability 10 minus 1. What happened? 10 minus 1? 9. Okay, what happened to the symbol? Less than. Then what we're going to get if we do the opposite? Greater than. The variable x become variable y. Okay, 10 minus 4, the symbol here first. Less than or equals to, it becomes greater than or equals to 10 minus 4, 6. Okay, there is no such thing in maths, these symbols, greater than and also greater than or equals to. You cannot do like this. Okay, rewrite in a correct form. The smaller value must be on the left. The higher value must be on the right. That is in maths. We cannot read from table. I make it both equals first. What is a number before 9? 8. So we have probability of y greater than or equal to 6 less than or equals to 8. We like to read from table. Okay, we're going to take y greater than or equals to 6. Okay, y greater than or equals to 6. And we're going to minus with, right? Minus with the number after 8. What is a number after 8? 9. Okay. So probability y greater than or equals to 6 is 0.1662. okay, minus with probability of y greater than or equals to 9, 0.0017. So we're going to get 0.1645. Next, probability of x greater than 3. If you do the opposite way, the x will become y, less than will become greater than will become less than. Okay, what's the value we're going to put here? 10 minus 3 is 7. The table cannot read less than. What we're going to do? What is actually the value before 7? Less than or equals to 6. So nampak je less than or equals to, kita buat 1 minus. Okay, so 1 minus, okay, what is the value after 6? Greater than, probability of y greater than equal to 7. Okay, so read from your table. Okay, probability of y greater than or equals to 7, 0.4. Okay, less than or equal to 7, 0.0548. Okay, so we're going to get 0.9452. Now the problem solving. Okay, a man sends 4 applications form to apply for shares in the company ABC. If the probability of each form to be successful is 4/5, find the probability that he is successful in 1 application, less than 3 applications, at least 3 applications. What is the random variables? How do we know the random variables? Look at the number. 1 application, 3 application. X means the number of successful application form. X has binomial distribution with n is 4. This 4 application is n. And the probability just now, 4/5, okay, is the P, right? So these are the parameters. What is 4/5 in decimals? 0.8. 0.8 where the probability is greater than 0.5. Okay, so you can read that from table. If we do the opposite way, okay, so our y, now x, it become y now, the new variable, the number of failed application form. So let us write down the parameters. Y is binomially distributed and it's still the same, but P now, for the new variable, 1 minus 0.8 is 0.2. Let us find using the opposite method. Okay, 1 application, probability of x equals to 1. We're going to write down probability of y equals to 3. Where does this 3 come from? 4 minus 1. We're going to get 3. The symbol for equals is still the same. If you're using the table, a probability of y greater than or equals to 3 will minus with the number after 3. The number after 3 is 4. So we're going to minus with probability of y greater than or equals to 4. Okay, so look at from your table, n is 4 and p is 0.2. Okay, n is 4, p is 0.2. So n is 4 here. Okay, p is 0.2. Okay, y greater than or equals to 3. Y is greater than or equals to 3. This one. Okay, 0.0272. Probability of y greater than or equals to 4, which is 0.016. Okay, so minus these two probabilities, we're going to get 0.0256. Now let's look for the probability that less than 3 applications. Okay, probability x less than 3. Okay, so change the variables. X become y, less than become greater than. Where this 1 come from? 4 minus 3. 4 minus 3 is 1. Okay, so we can use the table yet? No. Y greater than 1? What is the number after 1? 2. Okay, so now we can use table. And it's still 4. P is 0.2 greater than or equals to 2 here. Okay, 0.1808. At least 3 applications. So now let us change into maths. Okay, so probability x greater than or equals to 3. The minimum value is 3. So that's why we're using the symbol greater than or equals to. Alright, now let us use these, okay, parameters. This x become y, okay. Greater than or equals to becomes less than or equals to 4 minus 3 is 1. Okay, so we cannot use table. Okay, so kalau nampak je less than, we're going to do the complements. So 1 minus, what is the number after 1? 2. Okay, property of y greater than or equals to. This one we have found just now, okay, which is 0.1808. Okay, so tolakkan saja. Okay, we're going to get 0.8192. Alright. 6.2D, determine the mean and variance. Okay, this one the easiest one. Okay, so if x has a binomial distribution, the parameters is n, okay, and the property of success is p. If you like to find the mean, okay, another word for mean is expected value. So if the question asks about the expected age, it means the mean. Okay, we're going to denote with ex. Okay, ex. So this is another word for mean. The Greek word, the Greek alphabet. Sorry, mu. Okay, which is np. We just have to multiply these two. Okay, n times with the p. So if we're looking for the variance var x sigma square n times p times q. Standard deviation, just square roots your variance. Now let's find this. Let x has binomial distribution with n and p 0.22 and expectation of x equals to 11. Find the value of n. So we know that our expectation of x, or the mean, which is 11. Substitute your p into your np here. So this p become 0.22. Okay, so we're going to find the value n equals to what? What is your value of n? 50. Very good. How do we get 50? 11 will divide with 0.22. Alright, now what's next? What's the question? Variant of x. Okay, there are two ways to find the variant of x. So we know that the variant of x is npq, the first one. Okay, n is what just now? 50. Okay, p is 0.22, and where do we get this q? Where this q come from? 1 minus 0.22. Okay, so we're going to get 8.58. You can also do like this. So we know that the variance is npq. Okay, so np. What is np just now? np just now is 11. np is 11. So you're going to times with your q. You're going to still get the same, 8.58. Okay, sama je. Okay, same. Alright, cuma nak cepat lah. Okay, property of x equals to 4. So we already know the value of n, we know the value of p, we know the value of q. Just substitute into the formula. N is 50. Okay, c 4 here, times with 0.22 power 4. Okay, power 4 times with 0.78, which is the q. Where this 46 come from? 50 minus 4, 46. Okay, so you're going to get 0.059. Let's solve this problem in social sciences and management. Out of the pupils in a particular school, 45% go to school by bus. In a random sample of 30 pupils, calculate the mean number of pupils that go to school by bus. The probability that not more than 10 pupils go to school by bus. What is our random variables? How do we know our random variables? Find this word, the word probability. What this 10 stands for? This 10 stands for what? 10 pupils go to school by bus means the random variables is the number of pupils go to school by bus. You just have to replace this 10 with the general word, which is the number of pupils. Okay, so what is our parameters. Okay, this is a binomial distribution. Why do we call it binomial distribution? Because we have 45% that go to school by bus, so we're going to have the complement for the rest of the percentage, which is 35%. Maybe go to school by car, maybe they walk to school. This is going to be our P. So what is 30 pupils here? Stands for what? And very good. Okay, so we may write down as X has binomial distribution with N is 30 and P is 0.45. So this is a percentage. Change it into decimals. You cannot write down here 45%. No, cannot. Need to write down in decimal. The mean number of pupils that go to school by bus. So we know that mean is NP. N is 30, P is 0.45. Just multiply these two values. We're going to get 13.5. Next, the probability that not more than 10 pupils go to school by bus. So probability not more than. Okay, what does it mean? Okay, I think we've done this before. I think you may look at your notes. Okay, more than we're going to use the symbol of X more than. Okay, 10. But now we have the word not more than. We're going to use the complements. We're going to write down probability X less than or equals to 10. You cannot read this from table. What we're going to do is 1 minus. What's a number after 10? 11. So probability of X greater than or equals to 11. So look from your table. N is 30. P is 0.45 here. Okay. 0.8650. Okay. So we're going to get 1 minus 0.8650. Then the probability is 0.1350. A coin is tossed 40 times. Find the mean and the standard deviation of the number of heads appeared. What is this? N. This is N. N is 40. X represents the number of heads appeared. Okay. What is our distribution? What are the parameters? So X has binomial distribution where N is 40. Okay. Where this come from? 0.5. You toss your coins. What the outcomes? Head or tail. Okay. So the probability of getting a head is 0.5. Find the mean. Okay. Expectation X or the mean. Okay. Which is equals to NP. So multiply N and P. Okay. So we're going to get 40 times 0.5, which is 20. Okay. Standard deviations. Okay, so standard deviation is a square root of NPQ. So square root of 40 times 0.5 and times also 0.5, where 1 minus 0.5 is also 0.5, which is the Q. Okay, so you're going to get 3.162. That is the standard deviations. At the local swimming club, the expected number of members that can swim a mile is 4.5 with the variance 3.15. Find the probability at least 3 members can swim a mile. So we can't find the probability at least 3 because we don't know what is our N and we also don't know what is our P. 4.5 is the expected number and the variance is 3.15. We can find the value N and P. X is the number of members can swim a mile. Where did you get this X? Look at this number 3. Okay, so generally we can write down as the number of members can swim a mile. Expectation X is 4.5 or the mean is 4.5. So we know that expectation or the mean is NP. Okay, 4.5 and the variance 3.15. So variance is NPQ 3.15. So if you look at here, NP, this is also NP. Okay, so you're going to substitute your 1 into your 2. Okay, so you're going to sub 1 into 2. Okay, ganti saja masuk. We're going to get 4.5Q equals to 3.15. So you're going to find the value of Q, which is 3.15 divided with 4.5. We're going to get Q 0.7. So if Q is 0.7, what is the value of P? 0.3. Where does 0.3 come from? 1 minus 0.7. Now we already have the... Do we have n yet? No, we haven't found n yet. So we need to find the n first. So you may substitute any in the first equation or the second equation. I think the easiest one is the first equation. So substitute 0.3 into the first equation. You're going to get n as 4.5 divided with 0.3. N is 15. Now write down the distributions. X has binomial distribution. What is our n? 15 and P 0.3. Write down this. Find the probability that at least 3 members can swim a mile. Probability of X greater than or equals to 3. Boleh baca table terus tak? Boleh. Okay, you can read from your table. N is 15, P is 0.3. So what we're looking for, X is greater than or equals to 3. Okay, so you're going to get 0.8732.